Hello, today I'd like to introduce you to the topic Safe Dynamic Value Monitoring with the PNOZmulti tool. My name is Pilz. I'm an application engineer at Pilz. I like to start with a short example from a customer in Bremerhaven. They use wind-powered electricity to produce green hydrogen and store it in their trailers. The trailers are filled with hydrogen up to 380 bars. The challenge is to monitor the pressure rises and pressure drops when they're refueling the trailers. We are using our safe controller PNOZmulti tool with the base unit MB1, an extension module for the analog input module, and a relay output module to switch off the safety valve. For the communication to any other field bus device, we use a field bus extension module. To program your controller, you can use the license-free software tool PNOZmulti Configurator to set up all your function blocks. In the pre-assembled function blocks, you can monitor your analog input with 4 to 20 milliamps and detect a short circuit or a wire interruption. You can also use the pre-assembled ramp monitoring block to detect the pressure rise. I like to highlight the safety relevant accuracy of our analog input module. Each input has a tolerance of 1% and a safety level up to CL3. Now I like to show you the programming in our software tool PNOZmulti Configurator, and I jump into the software. After starting the PNOZmulti Configurator, we're placing our base unit PNOZmulti MB1. We're selecting our analog input module for AI and an output module for digital inputs for digital outputs. We are switching to our user program. In the user program, we have one program, it's the main program for the main controller, and a separate program for our analog input module. I select page 1 of the analog input module. On the right side, you can see our functions and different elements, logic elements, and different diagnostic features. I select the analog input module and place it on the left side. I select my input E0 and make signal smoothing to 10 milliseconds. I select the working range monitoring for the analog input module. Normally we work from 4 to 20 milliamps with a little bit of tolerance in there. It's according to the Namur NE 43. Starting type, you can select the starting type after arrow from automatic to monitored or manual start. I select automatic start and I use a equipment ID. In that case, it's sensor 1. For CL3 application, I need 2 sensors, so I select the second one with the same settings. To monitor the plausibility of both analog inputs, I'm using the function block for that. I can select different tolerance types, absolute tolerance or percentage tolerance or a mixture of both. I selected percentage and I leave it 0.1%. You can select a peak tolerance to filter a short period of peak current on your input, I'll leave it disabled. Now you can connect both analog inputs to the function block. In the next step, we can scale our analog input value to our physical value. Our lower value from the input is 4 milliamps and the upper value is 20, and we scale it to a pressure in bar from 0 to 1000. Now we connect our milliamp signal to the function block to get our physical value. To monitor the pressure ramp, we're using the ramp monitoring block. Place it here. We have two different options. We can monitor the upper limit or the lower limit. You can also see it in the picture on the right side. It's switching between the two types. Reset is automatically. I need to select a gradient of the pressure rise. In our case, it's 10 bars per second. I have an absolute tolerance from 1 bar and relative tolerance from 0.1%. And on threshold, it's the relative tolerance minus the on threshold when we switch back on our function block. I select 0.5 bars. You can see the legend with the different colors of the lines here. The blue one is the gradient. Then we put on top our absolute tolerance. Then the green line is the relative tolerance we put on top. And subtract our on threshold to switch back on our function block. The second input is an enable signal for the ramp monitoring. I take a connection from my module program. So I use a program connector input. So I get a signal from my main program, connect it with the enable signal, and I generate a program connector for the output using O0 to use my signal in the main program to switch the valve. In the next step, I'm placing a diagnostic block. It's useful to display the current value on the display of the PNOZmulti and send it via field bus out to any other device. Now I'm done with the configuration in my module program for the analog input module. I'm switching back to the main program. I select the button to switch on my ramp monitoring. I use input 0 and use a program connector. Now I'm using the program connector for my ramp monitoring function block in my main program. I select O0. Now I can connect that signal with all my other safety functions in the project, like emergency stop or safety gates, so that I only can switch on my safety valve if all safety conditions are okay. I select the digital output, semiconductor output, place it on the right side, and connect it with my ramp monitoring output. Now I'm done with my configuration. I can save my project. At the first time when you're creating a project, you need to set a password. Give the project a name. The next step, we download the program to the hardware. I go online. Open the project manager. Download to hardware. Save the project on the memory and activate. Restart the multi. After the restart, you can close the window. I go back to my Analogue module program. For the commissioning and maintenance, it can be helpful to take a look to the dynamic program display. In the dynamic program display, you see the current state of the values. You can add the numeric values to your variable list with a right mouse click on it. In the variable list, you can see now the current values, like the pressure or the current from your input. That was a short overview of our analog input modules to monitor your dynamic values. There are many more features available in our configurator. For more information, visit our website. Thank you for your attention.